Hey everybody, my name's Jeremy, and I'm a senior software engineer at Synadia. We maintain the open source high performance messaging system, NATS. Now today, we're going to talk all about NATS, and we're going to learn about how NATS can be used for microservice architectures. You're going to be surprised by how many things NATS can cover in terms of use cases for microservices. And so let's jump straight in. Now, at Synadia, we talk all about this concept of rethinking connectivity. And the reason we think this is really important is because in our traditional architectures, we've made some baseline assumptions about how things should talk to each other, namely one-to-one communication. And we want to be able to kind of expand our minds a bit and think about all the other ways that we can have our services communicate with each other so that we could build better applications. And we really think that trends like multi-cloud and edge are challenging these assumptions already, where we can't do what we've normally done in cloud for the edge and for multi-cloud. So let's talk about what we're doing today. Well, with today's technology, we're mostly relegated to doing things like DNS and hostname and IP for our service discovery. Sure, we might layer on another application to do discovery and stuff like that, but we're mostly using this to be able to discover where applications are and how we can talk to them. We're also leaning very heavily on this idea of poll-based request-reply semantics, namely using HTTP to be able to make requests and get a response back. And this is great, but it's not the only pattern that we can use in our tool belt. We also lean very heavily on this idea of perimeter-based security, where we can put all of our applications and all of our data inside of a VPC, put those walls up, and now everything's secure. But with the edge, where you need to move your compute and your data outside of your own four walls, that gets a little bit more tricky. We're also so used to these location-dependent backends where we have one big centralized database living somewhere in one data center, and the thought of being able to replicate and have data closer to you is a little bit of an obstacle. And all this culminates into just a lot of layers built on top of the HTTP protocol, and we've been doing this for years, and it's gotten really complex and really nasty, and we think that there's a better way. And this is where NATS comes in. NATS is an open source, high performance messaging system and a connective fabric. And really, it was designed to simplify the number of technologies that you use for your services to communicate. We also want to empower teams to build systems that are globally available, they're multi-cloud, they're multi-geo, and they're really highly adaptive to change and scale. And we really believe that this is at the heart of why people pursue microservice architectures, so they could scale their teams, so they could scale more globally, so they can make their applications more nomadic. But we think that the current solutions for microservices are really not up to that task. So let's talk a little bit about how NATS solves for this. First and foremost, we have this idea of location independence, meaning that a NATS application can live anywhere and it could call out to anything anywhere, and they don't really need to know where they live or what IP address it has. They really only talk about subjects. Secondly, NATS supports this idea of M-to-N communications, meaning not everything is one-to-one, but it might be one-to-many or many-to-one, or anything in between. This is a really powerful pattern that can give us a lot of runway. NATS also supports push and pull-based semantics. NATS is also push and pull-based, meaning you have a lot more flexibility in how you can implement your applications to be more reactive. NATS also provides this idea of decentralized multi-tenancy, meaning that applications can run and live anywhere and still be very secure. No having to put things in VPCs or having to go through all of these crazy proxies and firewalls and API gateways in order to get things working. We also have a system called jetstream, which is an intelligent persistence layer that lets you save data and move it around anywhere you want all over the globe. And it goes without saying that NATS was built for this global scale where you can create clusters and superclusters that truly span the globe and truly act as one system. And all of these things get to interact with each other as if they're right there in the same data center. So what's NATS architecture look like? Well, it's a simple server-client architecture. The server, it's simple, it's small, it's built in Go, and it's really, really fast. And it's composable into these all kinds of arbitrary topologies. So you can create, have a single instance running on a Raspberry Pi, all the way up to having a global supercluster that's crossing multiple clouds and crossing multiple geos all over the world. And then we have the client side, which the NATS protocol, it's just a simple text-based protocol. So we've been able to build 40 plus client library implementations. And we have first-class support for microservices, which we'll get to in this talk. As far as subsystems go, we have what we call core NATS, which is this high-performance fire and forget message publishing. And it provides for this idea of temporal coupling, meaning both clients need to be online in order for one person to receive the other's message. If you need temporal decoupling, you can resort to jetstream, which is our flexible, modern streaming and persistence layer. And the cool thing about this is all of this exists in one system, and they interact with each other in really, really neat ways. Core NATS is this high-performance fire and forget message publishing. You can think of a standard pub sub, but we've layered a couple other really neat things on top of it. And it's really fast, so you're able to scale to millions of messages per second on just a single instance. And we give you this flexible subject-based addressing, which is such an important concept to use when you're operating at a global scale. It's also payload agnostic, so if you want to use JSON, you can. If you want to use BSON or Proto, you can layer any sort of messaging format on top of that. Just a few of the patterns that core NATS will support out of the box is request and reply, publish and subscribe, fan in, fan out, scatter, gather, and it also does load balancing for free via queue groups, so no need to put a load balancer in front of your services. Jetstream, on the other hand, is this next generation distributed persistence layer, and it's built right on top of NATS core. And so it's more of an opt-in where you could say, hey, I want to start saving my messages somewhere. It's also multi-tenant, it's highly configurable, and it's globally scalable, which means it's just really fast to save data, to replicate it, to move it anywhere all over the world, and to do so in a very safe and secure way. With Jetstream, you get all sorts of streaming and persistence patterns that might sound familiar to you if you're used to using something like Kafka or Redis or Pulsar or anything like that. You get streaming, you get work queues, you get distributed logs, you even get key value stores and object stores, which is a really cool out-of-the-box way to start shuffling your data around and saving it. So I've talked a lot about NATS, but let's actually dive into a demo so I can show you how easy it is to work with. So I have my terminal window open here, and one of the really awesome parts about NATS is that it's just so dang fun to play with. Not only do we have a NATS server that's easy to fire up, all I have to do is I'm going to go over to my tab here and I'm just going to run NATS server. And there we go. We have a NATS server running locally on my machine. We also have a NATS CLI that gives you a bunch of different commands. This is basically a client library that I could just play around with inside of my shell. And this is what we're going to do today. We're going to use the NATS CLI. And so, like I said, core NATS is this idea of fire and forget message publishing, which means I could just type NATS subscribe, and I'm going to say hello.world. Now notice that we're using a subject that is separated by dots, which means I can subscribe to hello.world or I can subscribe to hello.star, and I would receive everything with hello.whatever it is. So I'm going to subscribe to that, and then I'm going to publish NATS pub hello.world. And I'm going to put a payload. Now remember that NATS is payload agnostic, so I can put whatever I want. But here I'm just going to put a string called hello. And you can see that the message is received. And I could just bump up that count to start sending a lot more messages, and you can see 1,000 are received. Like we mentioned before, NATS is really, really fast. So let's go ahead and run a quick benchmark. I'm going to say NATS bench, and let's look at right here. I'm going to send, I don't know how many millions of messages, 10 million messages, and kind of see how it performs. So right now on my machine, it's running at about 5 million messages a second, which is really, really fast. And so you can imagine how much more scale you could have if you go into a clustered mode or a super clustered mode. We also support this idea of request reply built straight into NATS. So I can say NATS reply to the hello subject with a hello. And now I can say NATS request hello, and I'm going to put hello, and you can see I've received my response as hello. Now, one of the cool things about NATS request reply is I can easily get load balancing for free using queue groups. So what I can do is I can say NATS reply hello, hello, and I'm going to do the same thing here, NATS reply hello, hello. And now I can start making requests. NATS request, hello. And I can start getting responses. As you can see, it's load balancing between the two. I'm just going to put 1,000 in here. And you could see that it's roughly been randomly distributed between the two. And this is a really neat feature of NATS because it means you don't have to put a proxy in front of your microservices. In fact, they could come up and come down as much as they'd want, and the load balancing happens automatically between them. If I wanted to start persisting messages so they could be read later, I can easily do that with jetstream. I'm going to start my NATS server with a JS flag to enable jetstream. And then I'm just going to start by creating a stream. I'm going to say NATS stream create, and I'm going to give it the defaults, and I'm going just to name this my stream. And it's going to ask me what subjects do I want to listen for and put into my stream. So I'm just going to put the subject that we've been using so far, which is called hello. All right, now my stream is created. I could say NATS stream list, and you can see I have 0 messages in my stream. Let's go put some messages in there. NATS pub hello, hi, and let's just put in about 10,000 of them. More like 100,000. All right, so we've saved all of those messages. Let's go NATS stream list again. You can see we have 100,000 messages in that stream. If we wanted to read back that stream, we could simply just go NATS sub stream my stream. And we've read all of those messages, and now we're caught up and we could start reading new messages as they come in. This is a very, very basic overview of Jetstream. We have so many more things like different consumer models. We have key value and object stores. We have so many different ways that you could read and persist and move around data. But just know that Jetstream is here, and it's a really, really neat, flexible, advanced way to be able to support so many different persistence models for your messages. Let's move on and talk more about how microservices and NATS are done. So one of the really neat things that the NATS client libraries give us is this little microservices-based framework. And the goal of this framework is to really challenge the status quo of how microservices are typically built. We wanted things like discoverability, observability, and the ability to move applications around wherever around the globe with 0 configuration changes. We wanted to make that all possible and out of the box simple. And that's where we created NATS Micro. So before we talk about how to use NATS Micro, let's talk about what's needed for microservice architectures. It's a long list of things. Not only do you have to build your application and possibly connect it to its own data store and everything like that, but then when you want these things to talk to each other, you need a load balancer, you need service discovery, you need logging and monitoring and observability, you need authn and authz, and you need an API gateway for all of your API calls, and then you need some sort of configuration management to configure all these microservices. And there's been a couple projects that have really tried to rope all of this stuff together, like a service mesh or things like that. But we think that NATS gives you really the ability to solve for all of these things just inside of NATS in a really, really simple way. And today we're going to go over just a couple of these, but I want to show you how NATS Micro makes it really, really easy to do things like discovery, load balancing, which we already saw a little bit of, how we can do monitoring and observability, and how we can really have this act as a really neat API gateway where we can even show schemas of how to call these things and how to implement clients for them. So let's jump straight back into another demo where I could show you everything about the NATS Micro library and how we can utilize it to have all of these things out of the box for free. The first thing I'm going to do is I'm going to use the NATS CLI just to demonstrate how the micro framework works. We have a really nice convenience command called NATS Micro. And I could say NATS Micro serve to serve just an example app, and I'm going to call this one again hello. And so this fires up a little microservice for us. This says it's an echo service called hello.echo. And what this allows, it allows me to say NATS request hello.echo, and I can put anything I want here. I'm going to say Jeremy is great, and it's going to echo back to me Jeremy is great. It's also put a couple headers here, which is really familiar if you're used to using HTTP for your calls. But one of the things that's really, really great about this is you get all the cool functionality of NATS, the multiple patterns, the persistence, the monitoring, all of that for free. Just because we're using a very kind of cool conventional way to be able to do service discovery for these. So let's hop over to our NATS micro list command, and I have this running every single second, but you could see that this hello microservice that we just put up here is actually showing up here. We see it's version 1, we see we have one instance of it, and here's an instance ID, and we have a little description of it, which is really awesome. I could also easily look at the stats for this microservice. I can say NATS microstats hello. And that's going to give me stats about this particular endpoint. You can see we have one request that I just made, we have 0 errors, and we have an average processing time. So I could simply make this request, I don't know, 1,000 times, and we could see that the stats will update and change, which is really, really cool. So now that we've run that little sample service, let's actually go do something a little bit more complicated. We're going to run a little calculator service, and I'm doing this in Go, but you can actually do this in a lot of different client libraries and languages. But I'm going to open up a quick microservice that I just put together. And again, this is all built in Go. If you're not familiar with Go, don't worry. This code is really easy to follow. So this is using NATS micro library to create a little microservice that adds, subtracts, multiplies, and divides. And the first thing that we do is we connect to our NATS server using the default URL. This means it's just going to connect locally to me, but I could point this to any sort of NATS server and connect into it. And then we go ahead and we add our service, and we decorate it with some data, meaning we have our version and we have a quick description. And this is here so folks can easily look this up in the service directory. And when I say service directory, I don't mean it has to register itself with the service directory. In fact, the way it works with NATS is NATS just makes a call out to all of the things that could be a service, and the services simply respond back to them with an M-to-N request reply pattern. And this is where this kind of stuff can get really, really powerful. Then I just add a couple endpoints like add, subtract, multiply, divide, and you can see I'm also decorating this stuff with extra metadata like our request schema and our response schema. And then I have handlers for each of these things, and they're very, very simple. I simply just parse the request data, and then I return a response with the appropriate math operation. And that's really it. There's not a whole lot to this microservice library. And if you're familiar with writing HTTP services, this is going to come really, really familiar to you. So let's actually go ahead and test this out. I'm going to run 10 versions of this service. There we go. Now we have 10 instances running. I'm going to go ahead and go over to this list command, and you can see that we have a calc service with a bunch of them running. We also have a hello service that's running as well. You can see that there's a simple calculator service, which is awesome. If we go over to stats, you can also see it lays out by instance every single endpoint and how many requests, errors, what their processing time is, everything like that, which is awesome. Now let's start making requests to this service. I'm going to create a new window, and I'm going to say NATS request calc.add, and I don't really know what to put here. I can say 2 and 2 maybe, and we're going to get an unable to parse request. So one of the things that we could do here is we can actually start using the NATS micro command to start discovering the service and seeing what we need to pass into it. So I'm going to say NATS micro info for this calc service. This is going to give me a lot of information. It's going to give me information for every endpoint. So we have our add endpoint, which is what I want to be using right now. And you can see that we have metadata like our request schema and our response schema. Now, I see that it has an A and a B JSON properties that I need to put in there. So that's probably what I need for my numbers. So we'll try that. But before we leave, you can see that we have this for subtract, multiply, divide, and we also get statistics for each endpoint. Now, all of this stuff is formatted so I can easily read it in the CLI, but all of this stuff also just has a JSON counterpart. This is all just JSON that gets returned. Whoops. This is all just JSON that gets returned when I run a NATS micro info calc, and I'll have it return JSON. And you can see that this is easily parsable by anything. So you can write programs that can give you even more information or record all of this information for you. You could build your own little schema registry if you wanted to, but there's a lot of really neat things that you could do with this convention. All right, so now let's try to call this service. I'm going to say NATS request calc.add, and then I'm going to pass in a JSON object somewhere. Now what we could do with the NATS CLI is I can just simply pipe in a JSON object. So I'm going to just generate a JSON object in my shell. I'm going to say A is 2 and B is 3, and hopefully I should get a response 5. And there we go. So we've received a response. The result is 5, which is really, really awesome. Let's go ahead and run this command 1,000 times, or more like 10,000 times. And let's look at that stats tab that we have over here. And you can see all of the requests were evenly distributed between them. And this is because NATS is automatically doing the load balancing. So we now have a set of applications that are automatically load balanced. We have automatic monitoring and observability for these. And we have automatic discovery, where we can even inspect the schemas and start using them. So you can imagine the types of applications that you could build when you have all of these things in front of you. And we didn't have to have any extra set of infrastructure. This is all using just NATS. One last thing that we don't have time to cover is all of these endpoints, the add, subtract, multiply, divide, are easily able to be locked down with authorization policies, so you can make sure that your microservices are adequately secured. And that covers the overall high-level overview of how you can use NATS to build awesome microservice architectures. And if you do have any questions about NATS or about how to build microservice architectures, feel free to put them in the chat below. We're monitoring them. And if you want to learn more about Synadia or NATS, you can visit synadia.com or nats.io. Thanks so much.